Uh, sorry, ma'am. It's also it's a circle. No, it's not a circle. It's a shape that has a base of a circle, and then it's long.
Okay. Do you maybe have a type of a container that of something that we use, probably we buy every day, that has a cylinder shape?
Ma'am, can it be like a toilet roll?
Yes, yes. Please, I want us to do that today, and let's see. I'm gonna share my screen now. Okay, are you guys able to see?
Yes, ma'am.
Okay, cool. So we're gonna look at cylinders, and do we have any question on what we were doing previously on Tuesday? Do we have any question? Before we carry on. Were you guys attending on Tuesday?
I did, ma'am.
Okay, cool. That means there is no question. Fine. So you have a cylinder, which is a what? A solid with two cycles as bases and a curved surface, which is not a flat surface. Okay. Therefore, although a cylinder is a prism, has two congruent parallel bases. Two congruent parallel bases. Kana, what did we say is meant when they say congruent or anything that has to do with congruency? What does that tell us?
They are the same.
They are the same. Perfect. So these are the bases they are talking about. They are the same. Yeah. And it is not a polyhedron. Not all the or not all the faces are flat polygons, right? If the cylinder is opened up and flattened, the net will be what? Will be made of two identical circle and a rectangular. So this is the net name. And then if this is if this is flattened, this one, and then you have what? Then you end up having the two congruent cycles or two congruent bases, and this rectangle that you see over there, right? The rectangle has the same length as the wait. The rectangle has the same length as the circumference of the circle, which is 2 pi r. The rectangle has the same length as what? As the circumference of the circles. So you see, they've given you a formula to calculate what? To calculate this length of the rectangle. Okay, so in case they ask you, if we have a question somewhere, when we do the questions, if they ask you, how do we calculate for this? Then you can use this formula because they say it is, or it has the same length as the circumference of the circle, which is that 2 pi r over there. And the width of the rectangle will be equal to the height of the cylinder. The width of the rectangle will be equal to the height of the cylinder h, which is for height there. Ne? Are we still together, guys?
Yes, ma'am.
Yes, ma'am.
Guys, I'm sorry about that. I had to wait. Okay, I am sharing a screen again. And this is the cylinders and then the curved surface. So when they cut it, it's curved, but when they flatten it, it's like this. You end up having this. So this is a demonstration of what has been said over here. Okay. And do we have any question on here?
No,
Do
ma'am.
we have any question? No question. Okay. Okay, cool, no problem. Now let's look at an example that we are given here. They say calculate the area of the surface of the following cylinder. Round off your answer to 2 decimal places. Calculate the area of the curved surface, excuse me, for the following cylinder. Round off your answer to 2 decimal places. So you have a what? You have a height of 15 centimeters, and then you have a what? You have a diameter of 14. Yeah? And let's see. Now, when you calculate for the area, the formula is given there 2 pi r height. Yeah? So we have 2 pi r height. The area of the curved surface is calculated using the formula, that one. And then the radius is going to be half of the diameter. So it's going to be half of the 14. The 14 is the diameter. So diameter is equal to 2r, 2 multiplied by r. And then if you want to know the r, you're going to say r is equal to the diameter divided by 2, okay? And let's see. The radius is 7 centimeters, which is half of the diameter. So it's 14 divided by 2, which is 7 centimeters. And then the length of the curved surface is 7, right? The length of the curved surface is 2 pi r. So you remember the formula that they've given us here, this one. The rectangle has the same length as the circumference of the circle. So this is the length of the circle, okay? So it's going to be 2 pi, this this r, and then you're going to get, what is it? 2 pi into 7. How much is it? Guys, are you having your calculators with you?
Ma'am, I get 14,98. I'm sorry, 43,98.
40?
No, 43,98.
So it's 43,98. There's nothing after this.
There's more decimals, but I just took the first two.
Okay, when you how many are they after comma? How
There's
many numbers?
1, 2, 3, 4, 5, 6, 7, 8. There are 8 decimals.
Okay, let's write them all.
Okay, it's 9822 9715.
9715. So when you're still calculating there, if you only round off the final answer, when you're still calculating, you don't round off there, because if you round off, your answer is going to be slightly wrong. It's not going to be the same as the one that they're expecting from you. It's going to be slightly different from the one that you're supposed to give. So we only
Sorry,
round.
ma'am. Sorry, ma'am. I wanted to ask, what? How do you do it on the calculator?
The pie.
Yes. Okay, ma'am. I see the pie, right?
Yeah.
But then I don't understand how Zira got her answer.
How much did you get?
Ish, ma'am, it's gone now.
What did you have on your calculator?
I need to, ma'am. We're using the 2 pi r with the 7 in brackets.
Yes, the R is 7.
Oh, the r is 7. Okay. And then, ma'am, I times it with 15.
Oh no, we don't
Oh,
multiply with 15.
we're not there yet.
Not yet.
Oh, okay. Sorry, ma'am. It's fine.
Yes. Now we are still calculating what? The length of the rectangle, which
Okay,
is this
ma'am.
one, the 2 pi r.
Oh, okay.
Okay, no problem. So now that we got that, it is also 14. Is it 14 pi? Yeah, it's 14 pi. But it's okay. And the radius is 7 centimeters, which is half of that. The length of the curved surface is 2 pi. That is the length of the thingy. This one, ne? This is the length, ne? It's what? Let's just say 14 pi to avoid writing all those long numbers. And then the width is 15 centimeters, same height as the cylinder. Same as the height of the cylinder, which is this one. This is the height, okay? That is the width. So the width is same as this one. Width is equal to height. Then the area of the curved surface area is equal to length times width. So the length is, we calculated the length, which is 2 pi r, and then multiplied it by height. Now, do you see how this formula has been used? The 2 pi r h. So the 2 pi r is the length of the rectangle, and then the h is the what? Is the height, which is the same as the width of this cylinder. And what is going to be? It's going to be 14 pi multiplied by 15 centimeter. 15 centimeter, and it's going to be, how much is it going to be? What is 14 pi multiplied by that?
Ma'am, I got 210 pi.
Oh, you also got 210.
Yes, ma'am.
And when you convert it, remove the pi, how much is it?
Ma'am, it gives me 659,7344573.
659,73459.
44573. No, ma'am, it's 57. Yes,
Okay,
ma'am.
no problem. So it's centimeters squared, because we are calculating for what? For area. Okay. Now they said the final answer must be rounded off to 2 decimal places, right? So we're going to have 659,73. And this is going to be the final answer. Now, do we have any question?
Ma'am,
don't,
I have a
ma'am.
question.
Okay.
I have a question.
All right.
I wanted to ask you about what happens to the 43,98229715. What happens to that?
It's this one. It's 14 pi.
Oh, this is 14 pi. Okay, I get it now. Thank
Yes,
you.
it's the same as the 14 pi. So if you don't want to say 14 pi, ne? Wait. 14 pi r is the 14 pi r. So because we calculated for 8, which is this one, so you can just say 43,98229715 multiplied by 15, which is the height. And how much are you getting? Type everything, all the numbers there. Let's see.
I get 659,7344573.
Okay. Now let's do this. You said you're getting the same answer as this one, yeah?
Yes, ma'am.
Okay. Now let's see. Now try to write it like this as 43,98. Remember the answer that you've given me earlier when you rounded off that, and let's see how much you're getting when you multiply with 43,98.
Ma'am, I got 659,7.
659,7.
Yes, ma'am.
And when you round it off to 2 decimal places, so it will be the same as 659,70, ne?
Yes.
So do you see that it is slightly different from this one?
Yes, ma'am.
Okay, let's see. Okay, let me try to do this. I'm trying to wipe here. Busisi, are you all good there? Any question from you?
Ma'am, I'm good.
Okay, cool. Now let's look at spheres. Do you guys know what a sphere is?
I do, ma'am.
What is a sphere?
It's a shape. It's a 3D shape that is completely round. It's completely round.
Completely round. Do you have like a common example of a spear shaped kind of thing?
A marble.
Yes. Perfect. And let's look at the sphere. So here they're saying a sphere is a perfectly round object in 3-dimensional space that resembles the shape of a completely round ball. It is not a polyhedron. Excuse me. The points on the surface of the sphere are the same distance from the center. Okay. The points of the surface of the sphere are the same distance from the center. Okay, cool. The radius is the straight line from any point of the sphere to its center. So any point from the center to the sphere or to any point of the sphere, it's the radius. So even if it's going there, even if it's going that, even if it's going that direction or down, wherever, but as long as it's from the center of the sphere to the point, right? And that means if it goes from a point, passes through the goes from a point, passes through the center, and continue with a straight line, then that is going to be what? That is going to be the diameter, okay? So if you are required to calculate the radius, or if you are required to use the radius and you are given a diameter, you know what to do. You're just going to divide the total with 2, because diameter is equal to 2r. So if you want r, you're going to say d divided by 2, and then you're going to get your radius, okay? They say of all the shapes, of all the shapes, a sphere has the smallest surface area for a fixed volume and the greatest volume for a fixed surface area. Of all the shapes, a sphere has the smallest surface area for a fixed volume and the greatest volume for a fixed surface area. For example, if you blow up a balloon, it naturally forms a sphere because it is trying to hold as much air as possible, as small a surface, yes, with a small surface area as possible, right? And the surface or the sphere appears all around us. Spheres appear all around us. Here are some of the examples. And then we have number 1 being pearl, and they come from oysters, and they are made into, or they are changed into this, the necklace. And let's see. Yes. It is interesting to note that the Earth is not a perfect sphere because it is slightly squashed at the poles, right? So basically, this is what they mean here. The Earth is called spheroid. Yeah. So if you are required to give an example of the sphere-shaped things, then we're going to leave out the Earth, all right? Do you guys see that?
Yes, ma'am.
Yes, ma'am.
Perfect. The sun is considered to be the most perfect natural sphere. So that means sun, you can use it as an example. According to the research published in the latest issue of the magazine Science, the sun is actually the most perfectly round object in the known universe. And then we have a soccer ball. A soccer ball is made from what is called a truncated. Ooh, Gosiam, what's this word? What's this word, Zira?
Is it isohedron? Isohedron.
ISO. What happens to SA?
Man, I don't know how to pronounce it. Isohedron. Hadron. Man, I don't know.
Okay, and how do you pronounce it? Busisiwe?
Ma'am, I pronounce it as a icosahedron or isosahedron.
Okay, so it's icosahedron.
Yes, ma'am.
Eh? Yes. Zira, are you with me there?
Yes, ma'am.
Yeah. So, what a ball is made from what is called a truncated icosahedron. This is a solid whose faces are made up of 2 or more types of regular polygons. two or more regular. So if you see, I get a polygon simply means the faces of a shape. So there must be more than five here. So you see here, you have a five shape, a thing, a five polygon, and here you have six. It's a hexagon and a pentagon. Do you guys see that? It's two shapes that are different, right? You guys see that?
Yes, ma'am.
Perfect. So when a truncated icosahedron made up of 12 regular pentagons and 20 hexagon is inflated, the flat regular surface become curved and the solid becomes spherical in shape. The flat regular surface become what? Curved, and the solid becomes spherical in shape. So it becomes roundish. Ne? And then a soccer ball is created in this way. There are also 60 vertices and 90 edges. So this you should also remember. Ne? How many vertices does a ball have, or how many edges does the ball have? So these are kind of things that they expect you to just know them. You don't have to calculate. You should remember, ne? In case they don't mention. And let's see, we have an exercise here. Exercise which we are required to do what? To use a volume, or to calculate for volume of a cylinder and a sphere combined or individually. So you may use or you may assume the following formula in the exercise: volume of a cylinder, surface area of that, and then you have volume of a sphere and the surface area of that. Okay, so here we just need to have an R, and here we just need to have R and H, ne? And let's see. The first thing that we're having here, which is A, volumes of both solids are below are equal. Volumes of both solids are below are equal. Now they're saying if the cylinder has a height of 10 centimeters and a radius of 3 centimeters, and the sphere has a radius equal to cube root of 67.5, show that the solids have the same volume. If the cylinder has a height of 10 centimeters and a radius of 3 centimeters, and the sphere has a what? Has a radius equal to cube root of 67.5, show that the solid have the same volume. So we're gonna use or make use of the formulas that we're given here. We just substitute, okay? And now what is going to be the volume of the cylinder? Volume of cylinder. Guys, are you still with me? Are we still together?
Yes, ma'am. I'm just calculating.
Okay. Busisi, where are you also calculating, or
Yes,
you
ma'am.
have something for me? Okay.
Ma'am, I guess
Yebo.
90 pi.
You get
I get
90
90. Yes, ma'am.
95 for cylinder or sphere?
For cylinder,
Oh,
90 pi.
90 pi. So
Yes, ma'am.
you substituted, you had pi into r. What is our r? Our r is
It is
3
3.
centimeters squared into 10. And you say you are having 90 r. No, 90 pi.
Yes, 90 pi, ma'am.
Okay. And which is the same as what? It has a lot of commas.
Which is equal to 282,
Comma.
comma,
Mm-hmm.
74,
Mm-hmm.
7, okay. It's equal to 282,
Comma seven
comma,
four
74,33388.
74,33388. Okay, cool.
Yes, ma'am.
And the second one, how much are you getting, or how much did you get?
I'm still calculating.
Okay, Busisi, how much did you get for the volume of a cylinder?
Ma'am, I also got 90 pi.
90 pi. Okay, cool. And for the second one, how much did you get?
Ma'am, for the
Volume,
sphere.
yeah.
Ma'am, I'm still calculating it.
Okay. So for this one, we have what? We have 4/3 pi into our r is cube root of 67.5 cubed. Yeah. Show that the solid have the same volume. If a cylinder has a height of z and a radius of z, and the sphere has a radius equal to cube root of 67.5, show that the solids have the same volume. How much did you get for the volume of a sphere?
Ma'am,
Mm-hmm.
can I see the answer?
Yeah, bo.
Ma'am, I got 90 pi.
90 pi. So now
Yes.
that the volume formula, we can give a final statement. I get they said show that the solids have the same volume. Did you also get the same answer, Zira? 90 pi.
Yes, ma'am.
Okay, cool. Now we need to give them the final statement because they didn't tell us or ask us to calculate for the volumes. They just wanted us to show. Well, now what's going to be our final statement?
That both the cylinder and the sphere have the same volume, 90 pi.
Perfect, perfect, perfect. Now let's move to number 2. Number 2 says, show that the sphere has a smaller surface area than the cylinder. Show that the surface or the sphere has a smaller surface area than a cylinder. So they're saying, show that this one has a smaller surface area compared to this one. So now we're going to calculate for the surface area of both. Then we can compare after. And let me do this with the dimensions that we were given. Go number 1, and we're going to use them on number 2. So we're going to substitute for the area. We can start with the area of a cylinder, which is 2 pi r squared plus 2 pi r height, and then followed by 4 pi r squared. Let's see, 2 pi r, no, we have a value of r. So our r is 3 and squared plus 2 pi. What is our r? Our r is 3, and our height is 10. And the next one, we have 4 pi into cube root of that, 67.5. Close the bracket. Wait. How much are you guys getting? So 2 pi r squared, 2 pi into 3 squared, plus 2 pi into 3 times height. So,
Ma'am,
mm,
ma'am, for the cylinder, I got 110 pi.
110, although not 190, 110 pi. So it's centimeter squared, I guess, because we are calculating for area. 110 centimeter, 110 pi centimeter squared. And what are you getting for the second one, Zira? 4 pi into cube root of 67.5 squared.
Ma'am, I'm just gonna quickly calculate it.
Okay.
Ma'am, I got 208,3270733.
Doesn't it have the pi?
No,
Can't you? Okay, cool. You say how much is it?
208, comma 3270733.
327. So let's just say 3 because it's the final answer, ne? Centimeters squared, ne? And what is 110 pi? 110 pi. When you convert it, it's 345.58 centimeters squared. So for cylinder, we have 345, and for sphere, we have 208. Show that the question of the requirement said, show that the sphere has a smaller surface area than the cylinder has a smaller surface area. So we literally just shown here because the surface area of the sphere is 208, and 208 is less than or smaller than 345. Okay. And do you have any question?
No, ma'am.
No, ma'am.
No question. Perfect. Now, they say draw a net for the cylinder and indicate dimensions. draw the net or draw a net for cylinder, indicate the dimensions. Do you remember the net that's shown as? Do you remember it?
Yes, ma'am.
Yes. So what you're supposed to do, you have to draw something like this. This is a net, okay? Either this way or this way. So basically, when they ask you to draw a net, you are basically detaching it, okay? Because it's different shapes. So you detach all the shapes. So you have a circle, and then you have a curved surface area, and then you also have another circle at the bottom, all right? So if we were to draw it, we're gonna have something like this. And we're gonna have a cycle. You can write it like this. Perfect. You can write it like this or draw it like that. So as long as the cycles are there at the and there at the top and the bottom. So this is how you're gonna draw it. And then let's say you have um a radius. So the radius is going to be like this. And what is the radius for? What is the radius for the thingy? The cylinder. What was the radius? It's 3, ne? Oh, okay. It's 3 centimeters. So this is going to be the 3 centimeters. And then they said the height is this one. So height is 10, all right? 10 centimeters. So this is how you're going to draw it if you are required to draw a net. Ne? Are you all good?
Yes, ma'am.
Okay. Now that we've drew that, let's look at number 4. They say calculate the length of the curved surface rounded off to 2 decimal place. Calculate the length of the curved surface rounded off to 2 decimal places. And do you guys remember how we're going to calculate for this? Do you remember the formula that we used to
Ma'am,
calculate?
is it pi? Is it pi? 2 pi r 2 pi r.
2 pi r. Perfect. Perfect. And let's see, where is that information there? Yes, it's this one. They said the rectangular has the same length as the circumference of which is the 2 pi. And what is going to be our answer is going to be 2 pi into 3, all right? So it's 2 pi times 3, which is
Ma'am, it's equal to 18,849.
18,489.
849.
18,849.
Yes.
That means it's going to be 85 centimeters, ne? Because what? Because they said you must round off to 2 decimal places. So it's going to be 18,85 centimeters. Do we have any question on that? Are we all good?
Yes, ma'am.
Perfect. Now let's look at the last question under A. They say calculate the area of the curved surface area rounded off to 2 decimal places. So now they want the area of what? They want the area of the curved thingy. How are we going to get that? Do you guys remember the formula that we're going to use? to calculate the area of the thingy, the curved rectangle?
Ma'am, is it 2 pi r times height?
Perfect. So it's going to be 2 pi r h, okay? And when you substitute, how much are we getting?
Ma'am, I get 60 pi, which is also equal to 188, 49.
How much?
188, 49. 5.
Okay. 2 pi r multiplied by h. So it's 2 pi. What was our r?
It was 3, ma'am.
3, and close the bracket. And our h is 10.
Yes, ma'am.
So it's 60 pi. But why do I feel like we're doing something wrong for this question? Okay, let me verify, ne? Let me go check that formula again. Let's see, it's 2 pi r multiplied by that. Okay. No, we are right. We are absolutely right. Okay, let's look at the B. Hopefully, we're gonna be able to finish the whole of it. So they are saying if the surface area of if the surface area of, okay, all right, let me back. If the surface area of a sphere is 36 36 pi, calculate the length of the radius. If the surface area of a sphere is 36 pi, calculate the length of that. Does anyone know how we're gonna do this? Or anyone who wants to try it? Let's write what you're thinking. How are we gonna deal with this?
Ma'am, is it going to be like, are we gonna add 36 pi with 4 pi?
And why are you saying that?
Ma'am, because both of them have pi, and so if we add them together and then times it by the radius squared, is that going to be correct? It's just I'm not quite sure. That's just what I think.
Okay, cool. Thank you. Thank you. We'll get on it. Busisi, what do you think? What's your take on this?
No, I'm not really sure.
What do you think we're gonna do?
Ma'am, I honestly have no idea.
Okay, cool, no problem. What we're gonna do here, guys, so we have a surface area that has been calculated, which amounts to 36 pi, ne? And then they used this formula to calculate the surface area of the sphere, okay? So that means they had something like this, 4 pi r squared, and then when they substituted the value of r, they got what? They got 36 pi. So it's going to be 36 pi. So 4 pi r squared is equals to 36 pi. Are we all together? Do you get me?
Yes, ma'am.
So what I'm trying to say is, let's say for example, their r was 6. So when they substituted 6 here, they said 4 pi into 6 squared, and it gave them 36 pi. So now we want to get this. We want to calculate for this. So we're just going to put r here because we don't know what's the value of r or what was the value of the radius. So we're going to say 4 pi r squared is equal to 36 pi, okay? Now we're going to solve for r. Are we all together?
Yes, ma'am.
Perfect. So the first thing we're going to do, we're going to divide with 4 pi because we want to be left with r, just r, name. So we're going to divide everything with 4 pi. So this will cancel that one, and then we are left with r squared. And how do we remove this square?
Can we use a square root?
Perfect. So we're going to make use of a square root. So we're going to have a square root of r squared, and then the square is going to be cancelled by the square root, and then we're going to have square root of 36 pi divided by 4 pi. Now that is going to be the value of our r, which is the radius. So our radius is going to be square root of 36 pi divided by 4 pi. And how much is that?
Ma'am, it's 9.
9.
Yes,
So
ma'am.
that means the radius is 9. That means the radius of the surface, no, the length of the radius is 9. I don't know if it's 9 centimeters or what, because they didn't give any dimension here, but I just assume that it's going to be centimeters because we've been working with centimeters, and also here it's a centimeter, but you can just say 9. You don't have to write centimeters or whatever, just 9, because there's no units that you're given here, like centimeters, meters, millimeters, or whatsoever. Okay, are we all good? Did we all understand?
Ma'am, I got 3.
You got 3.
Yes, ma'am.
Okay, let me try to substitute and then I'll see. 4 pi into 3 squared, and again, let's see, 4 pi into 9. How much do you get, Busisi, where 4 pi into 9 square? 4 shift pi into...
Oh, ma'am, I didn't square it, so maybe that's a mistake.
Okay, that one. Let's see, 36 divided by 4 pi. Let's see.
Yeah, ma'am, 3 is right.
Oh, you didn't put the square root, I see.
Yes, ma'am,
Perfect.
yes, that's my mistake.
Okay, cool. Then it's going to be 3. Our answer is 3. Our radius is 3, 4. Surface area of a sphere, if it's 36 pi, then our radius is that, or the length of the radius is 3 units. Okay, now let's look at number 2, and we have like a few minutes. Let's see. If the height of a cylinder is 10 centimeters and the volume is 160 pi, calculate the length of the radius. If the height of the cylinder is 10 centimeters and the volume is 160 pi, calculate the radius. And how are we going to answer this? If the height of a cylinder is 10 centimeters and the volume is that, how are we going to calculate for that?
Ma'am, can we say that 4 over 3 pi r squared is equal to 160 pi.
Wait, can you give me that formula again that you're using?
4 over 3 pi r cubed is equal to 160 pi.
Do you see what I've highlighted for you there in red?
Yes, ma'am.
And are you still saying that we're going to use that formula that you're giving me?
No, ma'am.
Perfect. And which one are we using now? The height of a cylinder is 10 centimeters and the volume of the cylinder is 160 pi. Calculate the radius or the length of the radius. Which formula are we going to use now?
We're going to use a pi r squared h.
Pi r squared h, and we're going to equate it with what? With 160 pi, because when they substituted whatever value of r and whatever value of h, it gave them this one. Hence, we are having pi r squared h being equal to 160 pi. Then now we have the value of height, then we can substitute the h. Ne? So we have pi r squared into 10 equals to 160 pi. And when you carry on with it, what do we do?
We divide it by pi.
We divide by pi. Divided by pi. Why don't we just divide by 10 pi? Because it's pi multiplied by r squared multiplied by that. Can we?
No, ma'am.
We can't. Okay, and what's gonna happen? What do we do? What's next? What's happening?
Ma'am, I think we get r squared open brackets 10 close brackets equals to 160.
R squared into 10 equals to 160. Okay.
Yes, ma'am.
So this will cancel, no, this one will be cancelled by that. This will cancel that. Okay. And what do we do now?
Ma'am, can we divide 10 in 160
Yeah, boy.
and in itself?
Yes. And that means we're going to be left with r squared being equal to 16. And what do we do?
We add a square root.
I couldn't hear you. What did you say?
We add a square root.
And we introduce the square root. So it's going to be square root of r squared equals to square root of 16. And what is the square root of 16? That is going to be the value of the radius.
It's
You said
4,
4.
ma'am.
4.
Yeah.
That means the what? The length of the radius is going to be 4 centimeters, because we have centimeter there. So it's going to be 4 centimeters. And then if you want to check your answer, if your answer is correct, you're just going to substitute 4 here. So you're going to have pi into 4 squared, and our height is 10. Yeah, height is 10. Yeah, it's 10. And then if it doesn't give you this, then we are absolutely wrong. So it's going to be pi squared into, how much are you getting? I'm getting 160. 160 pi. Are you also getting 160? 160 pi.
Yes, ma'am.
Okay, perfect. Do we have any question?
I don't have any questions, ma'am.
I also don't have a question, ma'am.
Okay, cool. Thank you for attending.